In this lecture, we will be studying about resonating cavity, active medium, metastable state, pumping, and population inversion. This is lecture 3 of Unit 4 lasers. So as mentioned, these are the various components of laser: population inversion, metastable state, active medium, resonating cavity, and pumping. In this diagram, you would see the first diagram you can see there are more number of particles in the lower energy state E1 compared to the higher energy state. This is because lower energy state is a state of stability and the particles like atoms like to remain in the lower energy state. When we give energy to the system, then what happens? The atoms absorb energy, and depending upon the amount of energy they have absorbed, they may go to the higher energy level, say a level E2 or E3. Here, in the third diagram, you would see the atoms or the particles get accumulated in the level E2. That is because E2 is a metastable state. We'll be studying what is a metastable state. That is a energy state in which the lifetime of the particles is more. So here, comparing the diagram 1 and diagram 3, you would see that in diagram 1, there are more number of particles in the lower energy state compared to the higher energy state E2. Whereas in the third diagram, you would see there are more number of particles in the energy state E2 compared to the energy state E1. This is what is meant by population inversion. Having more number of particles in the higher energy state compared to the lower energy state so that laser action can take place is known as population inversion. Now, assume there are a group of n atoms, each of which is capable of being in one of the two energy states. Let N1 be the number of atoms in the energy state E1 and N2 number of atoms in the excited energy state E2, where we know E2 is greater than E1 and N is equal to N naught exponential of minus h nu by kT, where N naught is the number of atoms in the ground state. Under thermal equilibrium condition, N1 is very much greater than N2. That is, the number of particles in the lower energy state is very much greater than the number of particles in the higher energy state. And hence, population inversion is not achieved. Population inversion is a condition in which N2 is very much greater than N1. That is, the number of particles in the excited state, higher energy state, is more than the number of particles in the lower energy state. This is a non-equilibrium state and exists only for a short time. Population inversion can be achieved by pumping techniques which transfer large number of atoms from lower energy state to higher energy states. Next, we can see what is a metastable state. Usually what happens when energy is given to a system, the atoms will go to higher energy state and come down immediately by spontaneous emissions. Whereas for laser action to take place, we need the atoms to be present in a higher energy state for some time. Such type of energy states are called as a metastable state. So atoms excited to higher levels have a short lifetime, about 10 to the power of minus 9 seconds, and drop to lower state by spontaneous emission. For population inversion to take place, atoms should wait in the excited state for some time. How much is that some time? It's about 10 to the power of minus 6 to 10 to the power of minus 3 seconds. Such an energy state is called as a metastable state. So if a particle goes to a metastable state, it will remain there for some time. When external radiation comes and strikes it, then they will come down. For laser action to take place, we need a metastable state. What is the active medium? Active medium is a material in which laser action takes place. It is a medium in which population inversion has been achieved. So once population inversion has been achieved, then that medium is known as an active medium. This diagram over here shows you what is a resonating cavity. What is a resonating cavity? A pair of optically plane parallel mirrors enclosing laser medium in between them is known as optical resonating cavity. One mirror is fully reflecting and the other is partially reflecting. So one side you have a fully reflecting mirror, the other side we have a partially reflecting mirror, and then this is the amplifying medium. When energy is given to the system, then photons are generated by the process of stimulated emissions. And these photons will keep moving towards the totally reflecting mirror and towards the partially reflecting mirror. They'll keep going up and down. And in this process, amplification of photons will take place. Suppose we start with 2 photons, it becomes 4, 4 becomes 8, 8 becomes 16, and the process continues. So this process over here is known as amplification process. Then when the intensity becomes very strong, laser output is obtained from the partially reflecting side, whereas no laser light comes out from the totally reflecting side. Now what is the role of an optical resonator? To provide positive feedback of photons into the medium so that stimulated emission is sustained and laser acts as a generator of light. It selects the direction in which light is to be amplified, that is, in the direction of optical axis of the mirror. Optical cavity makes the laser beam directional. It increases photon density through multiple reflections. It selects and amplifies only certain frequencies, causing laser output to be monochromatic. So for laser action to take place, we need population inversion, we need a metastable state, we need an active medium, and also a optical resonator. Now, pumping is the process of supplying energy to laser system to achieve population inversion. Pumping is giving energy to the system. Once you give energy to the system, we know that the particles or the atoms will go from lower energy state to the higher energy state. And when they are in the metastable state, they will come down from the higher energy state to the lower energy state. The various methods of pumping are optical pumping, which we will be seeing in ruby laser. Second method is by electrical discharge, which we shall be seeing in helium neon laser. There are various other methods of pumping by giving electrical current, okay, by chemical reactions. These are the various other methods of pumping. So pumping means giving energy to the system so that laser action can start. This shows you how a laser works. Okay, we have a resonating medium over here. Energy is given to the system. Few photons are produced. Initially, the production of photons may be by spontaneous emissions. Then it becomes stimulated emissions. These photons go to the totally reflecting side, come back to the partially reflecting side, and keep moving up and down. And in this process, amplification takes place. Because what does laser stand for? Laser stands for light amplification by stimulated emissions of radiations. In the last diagram, you will see when the intensity becomes very strong, some part of the light will come out as a laser light and the other part produces or gives rise to positive feedbacks. We can also study what is a 3-level laser system and what is a 4-level laser system. In this diagram, you would see there is 3 energy levels, say E1, E2 and E3. E2 happens to be a metastable state. So population inversion is between E2 and E1. But remember, large number of atoms are already present in the ground state because it is a state of stability. To attain a population inversion between E2 and the ground state requires a large amount of energy. Okay, so population inversion is created between the lower ground state and a higher energy metastable state. Such a system is known as a 3-level laser system. But remember, in a 3-level laser system, population inversion is between the higher level and the ground state, and large amount of energy is required. Here you would see a 4-level laser system wherein population inversion is between two higher levels. The ground state is not involved in population inversion. Since the ground state is not involved in population inversion, lesser amount of external energy is required to create population inversion. We do need a metastable state. The metastable state is present. In this example, a population inversion has occurred between, say, the E3 level and the E2 level. So that is what is a 3-level laser system and what is a 4-level laser system. So in this entire lecture, we have seen that we require an active medium. Active medium is a medium in which laser action will take place. For that, we require population inversion and a metastable state. And also equally important is a resonating medium for amplification to take place. So any laser that we take, all these components are required for laser action to take place.